Most adults have around 5 liters of blood circulating in their bodies to keep them alive. However, not all of us share the same type of blood, as getting the wrong type can be life-threatening. Now widely known as the ABO blood group system, we categorize A, B, and O type blood based on their structure. So in this video, we will go over why we have different blood types, how blood types are inherited, and what makes the blood types different. So why do we even have different blood types in the first place? We aren't entirely sure, but the most promising theory is to survive against different diseases. People with O blood seems to be more resistant to the malaria parasite, as their blood reduces clotting between healthy and unhealthy blood cells. This is why areas prone to malaria, such as Africa, seem to have more people with O blood, and why O blood is the most common blood type in the world. Malaria has been around before humans migrated out of Africa, so many of our ancestors passed down the O blood gene to people around the world. But despite that, there's a huge population of B blood in Asia and A blood in Europe, likely to build resistance to diseases there over thousands of years of evolution. Speaking of inheritance, blood types are a great example of dominant and recessive genes. Both the A and B blood are dominant or codominant, which means that if one of our parents has O blood and the other parent has either A or B blood, we would get the blood type of that parent. We can use a Punnett square to visualize how our blood type gets passed down. As you can see, since A and B blood are codominant, the resulting blood type will be AB. And even if we have an O blood allele, we will still have the blood type of the dominant allele. However, if we were to receive an O blood allele from both parents, we will have the O blood. A reminder that this is a huge simplification of how Punnett squares work, just so I can keep this video short. So now, what sets the different blood types apart? Our immune system is constantly checking our blood to make sure that everything in the bloodstream belongs to us. In order to prevent our own blood from being attacked, our blood cells developed antigens to tell our immune cells that they are just a part of us. A blood has A antigens, B blood has B antigens, AB blood has both antigens, and O blood has neither. Furthermore, some people also have the D antigen along with everything else. If they have the D antigen, we add the plus suffix, and if not, we add the minus suffix. So for example, if someone has the A and B antigens, but no D antigen, they have the AB minus blood. This is why it is important to donate the right blood for the right person, so our immune system doesn't attack the newly donated blood if the antigens don't match. This means that people with O- blood are universal donors, since their blood doesn't have any antigens that can trigger an immune response. Meanwhile, people with AB+ blood are the universal recipients, since their blood is used to seeing all the antigens. And there we have it. We evolved to have different blood types to be more resistant towards different diseases, starting from the O blood in Africa against malaria. Through dominant and recessive inheritance, our parents pass down their genes that determine what blood types we are. In the end, they're just different antigens telling our immune system to not attack our own blood. So of course, shout out to all the O blood donors out there, who makes it possible that everyone survives following a blood transfer. I hope that you all have learned something interesting today. Thank you for your time, and stay hydrated.